Alright guys, so for the last 2 days what we've been talking about is ionic bonding. Okay? We've named ionic bonds, compounds that have ionic bonding. Alright, we've also written the formulas for ionic compounds. Okay? And some characteristics that we talked about for ionic compounds include the following. First of all, they occur between metals and nonmetals. Alright? Another interesting characteristic is that at room temperature, they are solids, and this results because of the strong attractions between cations and anions that exist within ionic compounds. Room temperature. Alright, and another fact is that due to their strong attractions, the only time that they can conduct electricity is when they are dissolved. Only conduct electricity when dissolved in solution. Conduct electricity when dissolved. Alrighty. Now, I'm now going to talk about two other types of bonding. We've talked about ionic bonding, we've practiced with ionic bonding. Now we are going to talk about first metallic bonding, and then we are going to talk about covalent bonding. Alright? Alright, so if you'll flip to page 8 of your packet, okay, metallic bonding occurs between pure metals. Alright? And what you can see here by this picture that I've drawn, or that I stole from the internet actually, what you have here is your nucleus with your protons and your neutrons. Okay? And any pure metal, what happens with their electrons, instead of their electrons being held specifically by that nucleus or shared or donated specifically and having a specific purpose, what occurs instead is that they move freely, and what we call that is a sea of electrons. So they're going to move freely between atoms of that specific type of metal. Okay, it can be any pure metal, it could be copper, it could be aluminum, it could be gold, it can be any pure metal, but they're going to move freely, and so that's what these arrows are showing, those electrons moving freely. Now, that mobility of electrons, okay, that mobility of electrons is what results in the characteristics of pure metals that we've already seen. Okay? So one of those characteristics is the fact that they are ductile, meaning that you can take it and stretch it into wire, all right? Or that you can press it down and make nice little sheets that's malleable. So basically, unlike what you would have assumed with ionic compounds where you can't actually manipulate the shape of ionic compounds because they're so hard, with metallic compounds you can. They're ductile, they're malleable, you can change their shape, which is very nice if we're trying to make, for example, earrings or something like that. We can really manipulate their shape as a result of this sea of electrons. Alright? Another characteristic as a result of this sea of electrons, this easy movement of electrons, is the fact that metals conduct electricity. This free movement of electrons allows metals to conduct electricity. So they can conduct electricity even in the solid state. So while ionic compounds can only conduct electricity when they are in the liquid form, when they're dissolved, metals can conduct electricity both in the solid and in the liquid form. So that's another characteristic as a result of this sea of electrons. Okay? So some examples of where metallic bonding occurs. Any pure metal that you see has metallic bonding. So that would include copper, and I'm going to put solid because it's the solid form. It's not the ion form, not the ionic form. It's just the pure metal. Okay, so copper would be an example. Aluminum would be another example. Okay, any pure metal in the solid form has metallic bonding. Okay, so anytime you see a metal alone, it has metallic bonding. Alright, so there are your 2 out of your 3 types of bonding. You have ionic bonding, right, between a metal and a non-metal. Metallic bonding, where you have a pure metal and this free flow of electrons, okay, electrons moving about like a sea of electrons, which results in the ductile nature of metals and the ability of metals to conduct electricity. Okay? And then we're going to get to the last type of bonding. This is covalent bonding. Now, in covalent bonding, what's occurring, instead of a donation of electrons, in covalent bonding, electrons are shared. All right? And what occurs when we're talking about covalent bonding, instead of calling, for example, when we have ionic bonding, we call it an ionic compound. Okay? What we call a compound that has covalent bonding, we call it a molecule. Okay? And molecules result, or covalent bonding occurs between two non-metals. So a non-metal and a non-metal. Alright, so while ionic bonding is between a metal and a non-metal, covalent bonding is between a non-metal and a non-metal. Now, let's look at some of these characteristics of molecules. Okay, and molecules, remember, have covalent bonding occurring. Well, one of the characteristics, as a result of the fact that you're not donating the electron, instead the electrons are being shared, okay, there isn't going to be as tight of a hold, there's not going to be as tight of an attraction as there is with ionic bonding. So as a result, the melting and boiling points are going to be lower. Melting point and boiling point, I'm just going to show it with MP and BP, are lower. Okay. Another characteristic of molecules or compounds that have covalent bonding, okay, is that at room temperature, due to the lack of strong attraction, they're not actually solids. They don't tend to be solids at room temperature. They actually tend to be liquids or gases. So liquids or gases at room temperature. Alrighty. Now we're going to look really quickly at two different types of covalent bonding. Okay? We've got nonpolar covalent bonding and we've got polar covalent bonding. Okay? In nonpolar covalent bonding, your electron is going to be shared equally. Electrons are shared equally. Okay? So let's look at a really quick example. If we have, for example, hydrogen, okay, and the way we show a covalent bond, I'll review this later on, we show the sharing of electrons with a line. Okay? So this represents two electrons being shared. I could also draw it as H with two dots H because they are sharing these two electrons. Now, this gets back into the concept of electronegativity, which remember is the attraction for electrons. Okay, so hydrogen is going to be pulling these electrons. The other hydrogen is going to be pulling these electrons. Okay? In a nonpolar bond, if the two elements are pulling equally, if they're pulling these two electrons with equal force, okay, then it's considered to be nonpolar. Alright? If it's, let's go to polar really quickly. Alright? If the electrons are shared unequally, then it's called polar covalent bonding. Alright? So let's look at an example of this. Let's look at H. Okay, I'm going to show the two electrons with this one line, Cl. Now, if you look really quickly at your periodic table, decide which of the two elements is going to be more electronegative, Cl or H. Okay, so bring out your periodic table, look at your periodic table and decide which one's going to be more electronegative, Cl or hydrogen. And what you should realize is the fact that Cl is more electronegative because it's farther to the right, right? You increase electronegativity as you move to the right, and therefore Cl is literally going to be taking these electrons and it's going to be pulling it more towards itself. Okay, it's kind of like a tug of war, and Cl is pulling these electrons more towards itself. So as a result, there is an unequal sharing of those electrons. All right? Okay, so that's the end of these notes. What I want you guys to do right now, I purposely made this video a little bit shorter because I want you guys to take this time right now to go back to ionic bonding, and you're going to be looking at your polyatomic ions and study for the quiz that you have next period. We're going to finish these notes really quickly in class. It'll take, I don't know, maybe a minute or two, and then we're going to continue with practice once you guys have completed your polyatomic quiz. Alright, so make sure you guys are ready. I'll have a review up online for that, so check that out as well. Okay? Bye guys.